Hello, welcome to another module in this massive open online course. So we are looking at convolutional codes, and today we will introduce one of the most important concepts, the concept of a trellis, which is one of the most fundamental, I would like to say, aids or tools to represent and understand the convolutional code, and it is derived from the state space representation of the convolutional code. It is basically a time evolution of the convolutional code. So if you take the state evolution and unfold it or visualize it as a function of time, then what you get is a trellis based evolution of the convolutional code. Alright, so we will talk more about this as we go through the module. So this is the trellis based representation, talks about a trellis based representation of trellis based representation of the convolutional code, correct? And this is derived from the, as I have said, it is derived from the state. We have seen the state diagram or state space diagram. We have seen the state evolution diagram, correct? We have the state diagram represented, derived from the state diagram representation of the derived from the state diagram representation of the convolutional code. Okay, and as we have said, a trellis, this explicitly shows the time evolution. Okay, this shows the time evolution of it explicitly shows the time evolution of the convolutional code. So I start again similar to the state space diagram. I start, for instance, by drawing all the possible states, correct? For instance, one of the states is 0 0, other state, or let me just make some space here. So 0 0, 1 0, 0 1, 1 1. These are all the possible states at time j equal to 0. Okay, so these are, what are these? These are possible states at j equal to 0. And then what I am going to do, I am going to separately draw. Remember, in the state space diagram we had only one set of states. However, here in the trellis diagram, for each time instant we are going to draw the states separately. So this is the states at j equal to 1. Similarly, one can draw the set of states at j equal to 2. These are all the possible states at j equal to 2. So what I am doing, remember, I am drawing all the possible states at each time instant. I am drawing them in a line. Okay. So the first step is to draw all the possible, that is to represent, right, or to denote all the possible states at a given time instant. Okay, and for convenience these are represented in a single line. That's typically how the trellis representation looks. Okay, so all possible states each state. Now represent the time evolution. Okay, from j to time instant j to time instant j plus. Now how do we do this? For instance, again similar to the state space. Now of course, as we said, this is derived. You can think of this as an elaboration or an unfolding of the state. So it contains no additional information, but it's simply a convenience because it clearly represents the evolution, or that is the evolution of this evolution of the convolutional code as time progresses. That is, the state transitions, the various states, the initial state and the various states and the transitions between them as time progresses. That is what we mean by when we say the time evolution of the convolutional code. Okay, so now what we have here is basically 0 0. So if the input is 0, then this goes to, as we know from the state diagram, if the input is 0, it goes to 0 0. So now what we are saying is at time j equal to 0, if it is in the state 0 0, on arrival of 0, it gives output, that is C0 0 is 0, C1 0 is 0, and it transitions to the, so this transitions to the state 0. And on the other hand, if you have the input 1, then it goes to the state 1 0 and the outputs are 1 comma 1 at time instant j equal to 1. Okay, so this 0 0, you can see 0 input and output 0 0, this represents the top arrow, and the one written in bottom next to the state is for the bottom arrow. Okay, so this is for the top arrow. Okay, and this one output 1 1 is for the bottom arrow. Okay, it's just convenient to write it to the left of the now similarly 1 0, on arrival of 0, it goes to the state, that is if the input is 0, it goes to the state 0 1, so that is the top arrow. Similarly, now if I write the bottom arrow, if the state is, if the input is 1, output is 1 0 and it goes to the state 1 1. Now for the state 0 1. In state 0 1, if input is 0 1, if input is 0, output is 1 1 and it goes to the state 0 0. And similarly, if input is 1, output is 0 0 and it goes to the state 1 0. Finally, in the state 1 1, if input is 0, it goes, output is 1 0 and it goes to the state 0 1, that is given by the top arrow. And if input is 1, the output is 0 1. Okay, output is 0 1 and it goes to the state 1 1, that is given by the bottom arrow, that is given by the. Okay, so for each state at time instant j to each state at time instant j plus 1, here j equal to 0, so j equal to 0, j equal to 1, all right. From each state in j equal to 0 to each state, so at state j equal to, so at time j equal to 0, we have listed all the states, at time j equal to 1, we have listed all the states, and we are showing the transition, all the possible transitions from j equal to 0 to j equal to 1. And for each state at j equal to 0, there are two possible transitions. There is one that is indicated by the top arrow correct, and one that is indicated by the bottom arrow. For instance, if you look at 1 0, the top arrow denotes that on arrival of input bit 0, the output bits are 0 1 and it goes to the state. For instance, in state 1 0, it indicates that on the arrival of input bit 0, the output bits are 0 1 and it transitions to the state 0 1 at time instant j equal to 1. Okay. And now this convolutional code, remember, this same state diagram holds true at every time instant. So what holds for this first stage, or you can say stage 0, also holds true for stage 1, that is from time instant j plus 1, time instant j equal to 1 to time instant j equal to 2, and similarly from time instant j equal to 2 to j equal to 3, because the state diagram representation at every time instant is the same, correct, and therefore the evolution, correct, all the possible, the transitions, right, are the same. So this stage is repeated at every time instant. So what we have is again the same thing, top arrow, bottom arrow. Again, no need to rewrite this because it is the same as what we have at j equal to 0, that is top arrow represents 0, output 0 0, bottom arrow represents 1, output 1 1, and transition to state 1 0. Okay. So it is the same thing, again 1 0, top arrow, bottom arrow corresponds to input 1, correct, at 1 0, correct, at again 0 1, top arrow to 0 0 corresponding to input 0, outputs 1 1, bottom arrow corresponding to input 1, output 0 0, and finally again 1 1, top arrow corresponding to input 0, output 1 0, transitions to 0 1, bottom arrow corresponds to input 1, output bits 0 1, and transitions to 1 1, and this can subsequently be repeated for all time instants. Okay. So again it is a repetition. Okay, for time instants, for various, for all time, equal to block length. You will have as many, of course you will have as many repetitions as there are input, because for each input bit you will add one layer of these states to denote a transition from time at time instant j, that is the transition from corresponding to the input bit at time instant j, transition from time instant j, from the state at time instant j to the corresponding to the appropriate state at time instant j plus 1. Okay. So you repeat this, okay, and this diagram is basically this, which is, you can also think of it as an unfolded state diagram, and this is basically your trellis. So this basically shows the trellis diagram, alright, which is basically a time evolution of the convolutional code. Okay. And as we said, the trellis, let us note that also, that the trellis represents a time evolution of the convolutional code. It represents a time evolution of the convolutional code. Now further, or you can also say this is the unfolded state diagram. It is an unfolding of the state diagram. You can say it is an unfolding. It's an unfolding of the state diagram. Okay, that is basically unfolding of the state diagram followed by the repetition at various time instants plus repetition at various So if you look at the trellis, it's nothing but a block repetition of the state diagram. That is, whereas a state diagram is simply a representation of the states and the transitions. If you take the state diagram and represent it and repeat it sort of as a block at every time instant, so basically sort of unfold this state diagram, what you get is basically a trellis representation. Okay, and as you can see, it's derived. I mean, from the state diagram representation one can derive the trellis representation, from the trellis representation one can go back to the state diagram representation. Alright, so both are equivalent, except that the trellis is a much more convenient way to visualize the time evolution of the convolutional code. Okay, now other important point is observe that now observe, and this is important, this is a very important point on which everything that we are going to discuss further in convolutional code is going to observe that any code sequence observe that any code sequence corresponds to a path on this trellis. So any code sequence, and this is important, any code sequence corresponds to a path. What we mean by this is, for instance, if we look at 0 0 1 0 1, so let's say we start from 0 0, okay, so 0 0 and then we proceed to 0 0, let's say we proceed to okay, first 1 0 and 1 0 we proceed to 1 0 we proceed to, let's say 1 0 we proceed to 1 1, okay, time instant j equal to 1 we read state 1 0 and then we proceed to 1 1. So now you can see this state sequence corresponds to a path in the trellis, and that path is basically nothing but what is denoted by, if you can look at this, the path that I am talking is from 0 0 to 1 0 to 1 1. So what you see is any code sequence corresponds to a path in the trellis. I want to emphasize this again. So basically you can visualize it as, for instance, consider the state, for instance example, consider a simple example. Consider the state sequence 0 0 1 0 1 1. This is at time j equal to 0, this is at time j equal to 1, this is at time j equal to 2. Okay, this corresponds to a path, that is 0 0 to 1 0 to 1 1, and the transition 0 0 to 1 0, that generates the outputs. So these are the state transition and these are the code words generated. So 0 0 to 1 0, you can see 0 0 to 1 0, that corresponds to the bottom arrow, that generates 1 1, 1 0 to 1 1, that again corresponds to the bottom arrow at 1 0, so that generates the output 1 0. So this generates output 1 0, and as the states transition this country. So these are the code words that are generated, and so these are the state transitions. Okay, these are your state transitions. These are your state transitions. Okay, now however observe that observe 0 0 to 1 1 to 1 0. Now state 0 0 to 1 1. Now observe, this is not a legitimate path. This is not a legitimate path, because if you start with 0 0, there is no path, no transition that can take you to 1 1, correct? 0 0, there is no path to 1 1. So this is not a path, this is not, so there is no transition from 0 0 this does not exist. Hence this is not a legitimate path, and therefore cannot generate any code, cannot generate, and therefore cannot correspond to any code word. Cannot correspond, by which we mean that it cannot correspond to any legitimate code word that is generated by this trellis. Okay, that is the point. Now similarly, let's look at a code word sequence. We have looked at a state sequence. Now let us look at a code word sequence. Okay, so I will look at it similarly from the perspective of a code word sequence. Okay, so similarly, one one 0 0 1 0, this is not, we will show that this is not a legitimate code word. This is not a legitimate code. For instance, you can see 1 1 0 0 1 0. So 1 1, so let's say we start at state 0 0, we generate code word 1 1, which means we transition to 1 0. Now in 1 0, there is no input which generates the code word 0 0. You can either generate only 0 1 or 1 0, correct? So basically, let's say you start with the state. So we are looking at code word 1 1. So let's say you start at the state code word. So let's say you start at the state 0 0, you proceed to the state 1 0. Okay, so this is at j equal to 0, this is at j equal to 1. You are generating the code word 1 comma 1. This is fine, this is okay. But however, from 1 0, you can only go to states 0 1 or 1 1, okay, at j equal to 2. This corresponds to j equal to 2. You can either go to 0 1 and 0 1, and these generate code words. If you go to 0 1 or from 1 0, if you go to 0 1 or 1 1, these generate code words 0 1 or 1 0. So it's not possible to generate, it's not, so these generate code words, and these generate code words either 0 1 or 1 0. Therefore it's not possible to generate the code word, and these generate therefore it's not possible to generate both, neither of these transitions generates 0 0, correct? So neither of these transitions generates 0 0. Now similarly, on the other hand, if you can start at 0 1, the other possibilities you can start at state 0 1. So if you start at state 0 1, you are generating code word 1 1, which means you are going to the top branch 0 0. So 0 1, if you start, so this is not possible. So this combination not possible. We have eliminated this. On the other hand, other possibility. Now let us look at the other possibility. Other possibility is we look at the state and code word. A state is, let's say, 0 1 at j equal to 0. Transition to, well, 0 0 at j equal to 1, that generates 1 1. Some 0 0, you transition to 0 0 at j equal to 2, you transition to 0 0, that generates 0 0. Now from 0 0 you can either transition to 0 0 or this is at j equal to 3, you either transition to 0 0 or 1 0, and both these generate either 0 0 or 1 1. So it is not possible to generate 1 0. So none of these transitions generates, not possible to generate 1 0. So it is not possible to generate 1 0. Therefore, once again you see that this is not possible. Okay, not possible, again not possible. This is not possible. Okay, so therefore the code word sequence therefore the code word sequence 1 1 0 0 1 0, this does not correspond to a legitimate code word, or you can say does not correspond to a valid code word. This does not correspond to a valid code word. Okay, and therefore the most important thing that you have to realize is that if you are given a code word, right, if someone tells you that this is a code word that is corresponds to this particular convolutional code, then that has to be generated by a state sequence that has to correspond to a path. By a path means that has to correspond to a certain state sequence in the trellis, right, that has to correspond to a certain evolution of the convolutional code characterized by a sequence of states at the various time instants in the trellis. So I have to map any, so it's a, so given a state sequence or a path to the trellis, that corresponds to a code word, a valid code word, and more importantly, so this forward direction is fine, that is how we are generating, the convolutional code. Okay, now the reverse is also important, that is, if you have a code word that has to, if it is a valid code word, that has to correspond to a legitimate path or a legitimate sequence of states through the trellis. Okay, now that is important, this inverse mapping from code word to the path sequence to the trellis is important when we want to decode. Remember, at the transmitter we are coding, so all I am doing is basically corresponding to the information bit sequence, I am generating the code words, okay, or the code word. Okay, now at the receiver I have to precisely do the opposite, that is, given the code word sequence, I have to map it back to an information or an input bit sequence. For that it is important to realize that basically you have to map it back to a corresponding path through the trellis. That is the importance of this point. So, for decoding of convolutional code at the receiver, for decoding of convolutional code at the receiver, right? For decoding of convolutional code at the receiver, or let us put it this way, decoding of convolutional code at the receiver this implies that I have to basically find the input information sequence, which basically in turn implies that I have to find a path or map it to a corresponding path through the trellis. So, for decoding of the convolutional code, okay, I have to find the input information bit sequence, which means I have to find a corresponding path through the trellis, and that is what convolutional code, that is what the decoding of a convolutional code is all about. And this is what we are going to spend time trying to discover or trying to infer, that is basically how can one do this inverse mapping. That is, of course, we have looked at the generation of a convolutional code, the representation, state space representation, from that the trellis space representation, and the generation of the convolutional code word, correct. Now, the other thing that we are going to look at is, given a received code word, how to map it back to an information bit sequence, or to a path in the trellis. And from the path, of course, one can once you have the state transitions, that is the states at the various time instants, and valid state transitions, that is you have a valid path to the trellis, you can derive the information bit sequence, correct. So, like the path, right, the path can be used to automatically derive the information bit sequence, because every path, every transition corresponds to an input bit and the generated output code bits. Okay, so that is basically what we are concerned with, and which is very important in the to completely analyze convolutional codes and to understand the decoding aspect of convolutional codes, right. So, we will stop here and look at other aspects in the subsequent module. Thank you very much.